Okay, here we have the Jeopardy review game for Earth history. So starting off with the first one, in the category of sedimentary rocks, which type of rock forms after erosion and deposition takes place, and that is sedimentary rocks. What is the mineral in the rocks that reacted with the HCl, or hydrochloric acid, and that's calcite is the mineral that we were looking at in class. Which came first, the sand or the sandstone? With that one, we'd have to say that the sand or the sediment would have come first to create the sandstone. If we look at our rock cycle, we need to get sediment to get to sedimentary rocks. So we would say that the sand came before the sandstone. What happens to the sediments that get deposited in a basin? They get deposited, and the sediment starts to build up in flat horizontal layers. Then they get glued or cemented together, and they lithify or become rocks, and they start to harden. Calcium carbonate settles to the bottom of a tropical sea, and after a long time it turns into limestone. Fossils that often appear in this rock are from the shells of animals that fall to the bottom and become part of the rock. Blank is the breakdown of rock that takes place when rocks are broken into smaller and smaller pieces without changing their mineral composition, and that's going to be physical weathering. What came first, the Colorado River, the Colorado Plateau, or the Grand Canyon? For this one, we'd have to say that the plateau came first. The river then started to cut through the plateau, and that would have then formed our Grand Canyon, which would have come last. How are the rocks from two Grand Canyon sites related to each other? The definition of a layer explains that the rock layers are huge and extend over very, very large areas, in some cases multiple states even, and that's why we would see rock layers at different parts of the Grand Canyon, because they are massive. Looking at the rock sequence, how can you tell which rocks are older? The older rocks are always going to be at the bottom or further down in the rock sequence at a lower elevation. What would the Grand Canyon look like 6 million years ago? It would be a flat plateau. The Grand Canyon is only about 5.5 million years old, so 6 million years ago it would be a flat plateau. If we go back just a few million years, say 2 or 3 million years, the Grand Canyon would be shallower and narrower, but 6 million years ago it would be a flat plateau. What are some of the ways that mountains form? Mountains are going to form from collisions of tectonic plates. The blank in a tropical sea combines with blank, which is produced by living organisms to form a new substance called, and that's going to be oxygen, which is going to be combined with, calcite, which combines with carbon dioxide to give us calcium carbonate, and that's the new substance at the end. So that's going to be calcite, or calcium, combining with carbon dioxide produced by the living organisms to form calcium carbonate. How do fossils get into rocks? The remains of the animals are going to get into sediment and debris, and then they're going to get imprinted or pressed into that soil or sediment as it starts to lithify and harden. What affects crystal formation in igneous rocks? It's the speed at which they cool down. If they cool down very, very fast, they would be extrusive and have small crystals. If they cool down slowly, they would be intrusive and have large crystals. What causes tectonic plates to move? Tectonic plates, they float or ride on a river of magma that moves due to convection currents inside the Earth. So as that magma flows around, the tectonic plates kind of ride on top of that magma, almost like floating on top of a river of magma. How does sandstone form? Sandstone, or sediment and debris, and sand is going to get deposited in a basin, as it gets deposited in a basin, most likely in some type of like a desert area where sand and sediment is going to build up, get a little moist, and then start to liquefy or harden and glue together and lithify, where then it would get rock hard. How do igneous rocks form? Igneous rocks are going to form from the melting down or magma that then cools and hardens. And as that cools and hardens, that's going to give us our volcanic or igneous rock. And how do metamorphic rocks form? Metamorphic rocks are going to form from heat and pressure. As tectonic plates collide, it is going to put a lot of stress on the crust of the Earth, and that stress will then be in the form of heat and pressure, giving us then metamorphic rocks. What would have to happen on the Earth's surface for the Earth to form a layer of sandstone, then a layer of limestone, and finally a layer of shale? Well, for sandstone, we'd have to have a desert or beach area. For limestone, we'd have to have a marine environment, tropical seas, inland oceans, some large body of water. And for shale, we'd have to have some kind of swamp, wetland, forest area. So those would be the different environments. Okay. If we have a swamp, a sand dune, a swamp, and a tropical sea, that would produce what rock layers, starting with the swamp? Well, the swamps and wetland type areas are going to produce shale. Sand dunes would produce sandstone. Tropical seas would produce limestone. And, a swamp. So it would go shale, sandstone, shale, limestone. The rock cycle is the way that rocks get recycled or changed from one rock type to another. Why do earthquakes and volcanoes occur where they do? They occur at the collision or the interaction of the tectonic plates, or the boundary areas of those tectonic plates. And that's where the plates bump into each other, and there's a lot of pressure from inside the Earth escaping there and pushing on those tectonic plates in those areas. And the results are the earthquakes and volcanoes. What would have to happen to change granite into gneiss? Use your knowledge of the rock cycle to explain. Well, gneiss is a metamorphic rock, so to change into any type of metamorphic rock, we'd have to apply a lot of heat and pressure. For this one, we're going to look at igneous rocks forming from magma, sedimentary rocks formed from sediment, and metamorphic rocks formed from heat and pressure. Basalt and sandstone are two different types of rocks. Use your knowledge of the rock cycle to explain how basalt can change into sandstone. Well, basalt, being an igneous rock, would have to weather and erode and break down into sediment to then get into sandstone, which is a type of sedimentary rock. After testing a rock with acid, one of the rocks fizzed. What does that tell you about that type of rock? It tells you that that type of rock has calcite in it, or some type of calcium carbonate, and that it's a limestone. How do we categorize extremely long periods of times? With eons, eras, and periods. When we go back to our timelines, we use eons, eras, and periods. Obsidian is a glassy-looking extrusive igneous rock. Explain the appearance of obsidian using what you know about temperature and cooling rates and how they affect the crystal size in igneous rocks. Well, being an extrusive igneous rock, it's going to cool very fast, and it's not going to give the crystals a lot of time to form. So it would cool most likely at the surface of the Earth, or cool very fast because it's an extrusive igneous rock with very, very small crystals. What are non-renewable resources and renewable resources? So non-renewable resources, resources that are used up and they can't be replenished. And renewable resources are resources that we're not going to run out of, or they can regenerate or regrow within a human lifespan. Non-renewable resources, fossil fuels, nuclear energy. Renewable resources, solar, wind, water, geothermal, biomass. What's the difference between renewable and non-renewable resources? It's like I said in the last question, renewable resources are going to be able to regenerate within a human lifespan, or they are things that can't be used up, like solar energy. Non-renewable resources are things that we have a limited quantity of, and they can be used up. Renewable resources are not quite as effective and efficient, at least as today, as non-renewable resources. We get a little bit more energy out of non-renewable resources when we go kind of pound for pound and look at the output of the energy source for that resource. When we look at the final Jeopardy question, what are some ways that rocks get broken down? Give at least one physical and chemical example. So with physical weathering, we can look at frost wedging, which is probably one of the more common ways that rocks get broken apart. With physical weathering, they're going to break apart and they're going to remain the same chemical type of rock. It's just going to be broken down into smaller pieces, but it's going to be chemically the exact same as it was when it started. With chemical weathering, we're going to be looking at some kind of chemical change that's going to take place, usually some kind of acid or acid rain that's going to break down the rock. A lot of times we'll get lichens or different plants that will add nitrogen to soil even, and that would over time break down rocks chemically, where it would wear away at the minerals inside the rocks and change what the rock consists of. So that would be an example of chemical weathering, where we're going to have usually water and some type of acid mixed together that would slowly wear down the rocks. And that brings us to an end of the Jeopardy review game and the review. Good luck on the test.